All right, this is Algebra 1B Part 2, Unit 2, Lesson 2, Operations with Radical Expressions. We've already covered how to simplify radical expressions by factoring, writing as prime factorization, and then pulling out pairs. We're going to add, subtract, multiply, and divide rational expressions or radical expressions in this. Okay? So to add or subtract, the thing to remember there, to add and subtract, you must have like terms. It's basically combining like terms like you do in your algebra class. So let me give you an example. 4 root 7 plus 3 root 7 is 10 root 7. Add the coefficients, add the numbers in front. If I have 4 root 7s and 3 root 7s, combined, I have 10 root 7s. So add the coefficients. That's called combining like terms. And the same thing applies to subtraction. Okay? So if I have 8 root 3 minus root 3, by the way, if there's no number in front of the radical, the number is assumed to be 1. So 8 root 3's take away 1 root 3 is 7 root 3. So this is 7 root 3. Okay, so only like terms. Don't do this. Don't do root 2 plus 5 root 3. Don't go adding them. You can't do anything with them. It's simplified already. There's nothing else you can do to simplify that by adding anyway. Okay? All right, that's how to add or subtract. Now to multiply or divide. Okay, multiplying. Let's handle or cover and talk about multiplication. So root 5 times root 15. Okay? Basically the idea is you can combine radicals across multiplication. So this is the square root of 5 times 15. Now, based on what we learned last lesson, 15 is 3 times 5. So this is 5 times 3 times 5. And I can pull out a pair of 5s. The square root of 5 times 5 is 5. So 1 5 comes out. All that's left in the radical is the 3, 5 root 3. Okay? You can do that with variables even. So 4x squared, or actually let's do x cubed square root times the square root of 8x to the 5th. Okay? So you can combine that under one roof. 4x to the 3rd times 8x to the 5th. Expand it out. 4 is 2 times 2. X cubed is x times x times x. 8 is 2 times 4, which is 2 times 2. X to the 5th is x times x times x times x times x. And look for pairs. Okay? So I have a pair of 2's that come out. A pair of x's that come out, a pair of 2's that come out, a pair of x's, and that's an x, not a 2, and another pair of x's, and here there's another pair of x's. Okay, so everything that comes out is 2, 1, 2, 2 2's, and 1, 2, 3, 4 x's. Okay, and what's left inside is a single 2, so we can simplify that to 4x to the 4th root 2. Okay, so that's multiplication. The other thing you need to be able to do is divide. Okay, and that's a little bit tricky. We do something called rationalizing the denominator. Let's do that here. Let's bring up a new page. Okay. All right, so let's say I've got root 8 divided by root 2. Root 8 divided by root 2. That can be written in fraction form as square root 8 over square root 2. And in reality, you can, just like you can extend a square root, a radical, over a multiplication, you can do the same thing for division as well. Square root of 8 divided by 2. And 8 divided by 2 is 4. And the square root of 4, or if you want to expand it, 2 times 2 is 2. Okay? All right? But what if you have like a whole number divided by, right? So 9 divided by square root 2. Well, we write that as 9 divided square root 2, but we do something called rationalizing the denominator. We don't like a square root in the denominator, so we multiply top and bottom of the fraction by the square root 2. Okay, 9 square root 2 on top, and root 2 times root 2 is root 4, which is just 2. A square root times itself is itself. Okay, so this is called rationalizing the denominator. So 9 divided by root 2 is the same as 9 root 2 over 2. Okay, and there's one last thing, one last skill, using the conjugate to simplify something. Let's say I've got 9 over root 2 plus root 3. Okay? You can actually simplify in this case by multiplying by something called the conjugate of the denominator. The conjugate is the same thing, root 2 and root 3, but with a different sign. Instead of root 2 plus root 3, do root 2 minus root 3. And as long as we multiply top and bottom by the same thing, we're legal, because you can multiply the top and bottom of a fraction by the same thing. Okay? Now on the top we just get 9 root 2 minus 9 root 3. On the bottom we get this. Let me multiply this out first. Root 2 times root 2 is 2. Outside, root 2 times root 3 is root 6. Inside, root 3 times root 2 is root 6. Root 3 times root 3 is 3. Okay, notice what happens to the middle terms. We have negative 1 root 6 plus 1 root 6. Negative 1 plus 1 is 0, and we end up with 2 minus 3. 2 minus 3 is negative 1. And I can now break this up over the division, over the subtraction here. 9 root 2 divided by negative 1 is negative 9 root 2. Negative 9 root 3 divided by negative 1 is plus 9 root 3. And I prefer to write it this way, 9 root 3 minus 9 root 2. Okay? And so that is considered simplified. We have gotten rid of the denominator by multiplying by the conjugate. That's probably the most complicated part of the lesson.